Hello guys, welcome back to Foolish Engineer. The high voltage BMS is made up of three main blocks. The cell monitoring units, also called as slaves, that measures and balance individual cell voltages and temperatures. The battery management unit, also called as the BMS master, that makes the big decisions and manages charging, discharging and communication. And finally, the battery junction box that handles connections, current sensing, and isolation. That's all. We are going to go deeper into these. So, let's start. We have already seen the difference between a low voltage system and a high voltage system and their BMS in older video. And so far, I imagine you guys know what a BMS is and why do we use it. So let's cut to the chase and see the BMS architecture. Let's reimagine a battery management system as a school, where discipline, performance, and safety are non-negotiable. Let's meet the staff and students that keep this high voltage institution running smoothly. Every school starts with its students. In our case, we have got hundreds of them, each with different personalities. Some are eager overachievers, always at full energy. Others are digging their feet, barely holding the charge. A few a little too hot headed for their own good. They need constant supervision, individual care, and sometimes a reality check. In a battery system, these students are the individual battery cells. Each cell has its own voltage, temperature, and charge state. Even though they are in the same pack, their behavior can vary widely. And if one cell misbehaves, it can compromise the safety and performance of the entire system. That's why monitoring them individually is absolutely critical. Now, no school can function without teachers, right? Every teacher is responsible for a small classroom, keeping a watchful eye on their students. They keep attendance, check for fevers, and make sure no one's acting out. If a student has too much energy, they calm them down. They don't discipline harshly, but they do balance things out. These teachers are the cell monitoring units or CMUs where the analog front ends are mounted. Each CMU watches over a group of cells measuring their voltage and temperature in real time. They also handle cell balancing, bleeding off a bit of energy from the stronger cells so everyone stays in sync. Then they report the status of their entire classroom to the head office. They are the front line to the battery management system. At the top of the school, there is the headmaster. It doesn't monitor individual students, but he knows everything that's happening. He makes the big decisions like when to start the classes, when to send students home, and when to shut things down completely. He is in constant contact with other institutions, the school board, and emergency services. He also keeps performance records, makes sure safety protocols are followed, and never misses a red flag. In the BMS, this is the battery management unit, the BMU. It collects all the data from the CMUs and make high-level decisions. It calculates state of charge, state of health, and ensures cells are within the safe operating ranges. If anything is out of spec, it takes action reducing power, initiates shutdowns, or alerts the system. It also communicates with the rest of the vehicle, motor controller, charger, and the dashboard. The BMU is the brain of the entire operation. Every school has a security office. They control who gets in and out. They open the gate in the morning and lock everything down when needed. They monitor everyone entering the premises and make sure no one's sneaking dangerous items in. And if something goes really wrong, they can trigger a full evacuation. In the BMS world, this is the battery junction box or BJB. It has the big contactors, the high voltage switches that connect or disconnect the battery pack from the car. It includes the current sensor, monitoring all electrical traffic. Sometimes it has a pre-charge circuit to prevent dangerous inrush currents. It watches for isolation faults. And yes, it even includes a pyro fuse, a one-time explosive disconnect in case of emergency. The BJB is the muscle enforcing safety at the pack level. Before we dive deeper into each block, remember that there are two main flavors of BMS architectures as of now. One is wired and other is wireless. Usually the cell monitors talk to the BMU over a wired communication, but newer systems use wireless BMS where each cell module sends data via radio frequency. We'll check more on that later. Let's go more deeper into each block. One of the key reasons I started this YouTube channel is to bridge the gap between the outdated Indian education system and actual skills needed in the industry. Well, if you're a student, you can use and learn an industry leading EDS software, Altium, for free by using its student lab program, which narrows down this gap. You just need to use your university email to enroll, and you get a full student license, a full PCB design course, and a certificate recognized by top Indian core electronics industries. Altium isn't just one PCB design software, but it is a whole platform of capabilities for electronics design. I've personally used Altium since the start of my electronics journey, and I honestly recommend it. It's a fantastic way to enhance your skills and increase your chance of landing a job in a core electronics company. So don't miss this golden opportunity. The cell monitoring unit takes care of each cell. We already saw how a BMS takes care of each cell in this video. If you have already watched that, then you can skip this and go to this timestamp. First is measuring the cell voltage. Voltage is like blood pressure of a battery cell. Either too high or too low is bad news. The CMU measures each cell's voltage with high resolution and accuracy. High resolution is needed because small differences matter when we have, say, hundreds of cells in series. Even a 10 millivolt error can add up to a big error on the whole pack. If the voltage is blood pressure, temperature is like body temperature. It is very critical for safety. The CMU reads temperature sensors because batteries hate getting too hot or too cold. So monitoring that helps the BMS know when to cool things down or dial back the current. Next is cell balancing. Now here is a bit of magic. No two cells are identical. Over time, some cells hold slightly less charge than others. If unchecked, one weak cell can limit the entire pack's usable energy, and balancing fixes that by evening out the charge across the cells. There are two main balancing techniques which are commonly used: passive cell balancing and active cell balancing. We'll go deeper into this concept in coming videos. Each CMU typically communicates the measurements to the BMU through a daisy chain communication, so that the BMU gets real-time stream of each cell's health report. In short, the CMUs give our battery pack eyes and ears on every cell. So if anyone asks why fuss about measuring each cell, tell them it's so the BMS can squeeze maximum performance safely without damaging anything. All those cell measurements are great, but someone needs to make sense of it and take action accordingly. That's where the battery management unit, the brain of the BMS, come into picture. This is usually a microcontroller or a processor that pulls in data from the CMUs and make decisions. It mainly takes care of collecting and analyzing data which came from the CMUs, like the cell voltages, temperatures, back currents, etc. It then runs algorithms to calculate state of charge and state of health and other important things. Based on the data, the BMU decides if it should allow the car to keep discharging or charging at certain rates. If something is critically wrong, say a cell overvoltage or an isolation fault, the BMU can initiate a shutdown. In the HV BMS, we use big high current contactors because we are talking about 400 or 800 volt and current in the range of thousands of amperes. And the BMU controls these battery pack contactors. It controls how to charge and how to discharge the battery. The BMU typically communicates with other vehicle controllers like the motor inverter, charger, or vehicle control unit over CAN or other networks. It reports the battery status like SOC, fault, or remaining power. Given its safety critical nature, BMUs often have redundancy. So, in the modern architecture, redundant measurement channels and controllers are used to achieve the highest functional safety so that if one part fails, the BMS can still safely manage or at least shut things down gracefully. After all, when we are driving at 100 kilometers per hour in an EV, we really don't want the battery brain to crash or misjudge something. Now, let's talk about the battery junction box, the part of the BMS that interfaces the battery pack to the outside world. If the BMU is the brain, the BJB is the security muscle. Its job is to connect or disconnect the battery pack, measure high-level vitals, and protect against electrical faults. So, basically, BJB has high-voltage contactors, which are big electromechanical relays or solid-state switches that connect the battery to the car's powertrain. When we turn on the car, the BMU commands the contactors to close, connecting the battery pack to the inverter, enabling the car to drive. When we turn the car off, the contactors open to isolate the battery. Think of them as the main gate of the battery's energy. Ever plugged something in and see a spark? That happens because of the inrush current, and it will rise up enormously to charge the empty capacitor present in the other subsystem in the vehicle. To know more about the inrush currents, you can see this video. To limit that inrush current, we use a pre-charge circuit. It's basically opening the door smartly and slowly before letting the crowd rush in. There is always a first for safety. One-time sacrificial element that blows if current is way too much or short circuit or crash scenario. Many modern EVs also include pyrotechnic fuse. We'll see about that in detail in coming videos. The BJB usually has the battery pack current sensor. We have already seen what a current sensor is and why it is so important in this video. This is battery's fitness tracker. As we know, high voltage packs must be isolated from the car's chassis for safety. So the BJB also takes care of that. In some designs, the BMU and BJB are physically together. In others, the BJB is a separate box with its own controller that communicates to the BMU. But we'll talk about that later. In summary, the BJB is all about high voltage protection and power flow control. It connects the battery when it's go time and disconnects when it's unsafe or stop time. So that's the BMS architecture, like a well-run school with students, teachers, the headmaster, and security team which never sleeps. Coming up, we'll break down each of these blocks with real components using TI's references and products to get real-world know-how. If you found this video useful, give it a thumbs up, hit subscribe button, and stay tuned for more exciting content.